Perfect. Okay, hello everyone. Welcome to this week's CGIL seminar. I'm delighted to welcome Michelle Axford, who has graciously agreed to wake up at 5:30 in the morning to join us here for a seminar. Michelle is a Latrobe University PhD candidate with the Dairy Bio Group, focusing on the genetics of calf vitality. For Datagene, she contributes to projects that support the growth of heifer genomic testing on a part-time basis. Michelle and her husband own and operate a family dairy farm business based in the Gippsland region of Southeast Australia. Over the past decade, Michelle has focused on making Australian breeding values more accessible through the Good Bull strategy and better aligned with farmer and industry expectations and more clearly validated in Australia's varied dairying environments. In her prior role at Datagene, she led the last two national breeding objective reviews and played a key role in the implementation of Datagene's new genetic evaluation software. And with that, I'll pass it over to you, Michelle.
Thank you so much, Colin. Look, it's just lovely to be with you guys today. I look forward to the next little bit and your questions and thoughts on what I thought I might share with you today. Now, my husband and I have two children. They're 18 and 20 years of age. They probably wouldn't describe me as a particularly good listener, especially when it comes to hearing why the household chores haven't been completed. But when Colin was talking today about the topic for the seminar, there were a few suggestions, and one thing that tied them together nicely was the role of listening. And listening particularly to farmers, listening to them explain the problems that they're having, and you know, that useful step in co-developing better solutions through research, development, and extension. And so that's the reason why I thought I might title today's presentation The Genetics of Listening, but maybe it's actually about the listening of genetics. I find it a bit ironic that today I'm speaking with a group of people in Canada, my home country, because it's at the same time that the Royal Winter Fair is on, and especially one of the highlights of the fair being the Black and White Holstein show. And for 100 years, farmers have traveled to the Royal to meet, to compete, to share ideas, to learn, and to listen. Maybe also to eat cinnamon buns and get free hats that usually have some sort of Seaman Company logo well placed on it. Now, I was a kid from a farm in Ontario, a dairy farm in Ontario, and the Royal was one of those places where that seed was sown about the opportunities to work in a broader ag industry, the value of the networks that the community brought, and the idea of being a Guelph Aggie. I just loved seeing those Aggie jackets walk around the Royal Winter Fair. So I find it really ironic that today's the day that I get to speak to you, at the same time. But the cows where I live look a little differently at the moment. So I'm talking to you about genetics, but not from my homeland of Canada, but from my new homeland of Australia. And the tools are no longer the show halter or the set of clippers or the boule boots, but rather statistical models, computer clusters, and listening ears. And it's that listening ears that I'm going to focus on a little bit today, especially explaining what I think are some of the interesting or novel bits that you might find fascinating about the Australian genetic evaluation system and the way that we offer services to farmers here. Australia is a big country like Canada. If you drove from this place in Melbourne up to Darwin, which is way up here in the top of the country, that's like driving from Guelph to Jasper. So it's not as big as Canada, but it's still a pretty big place. And while the majority of farms are pasture-based farms, they're intensive grazing systems, our country actually covers about 5 different feeding systems, from complete grazing with virtually no supplement being used through to fully housed TMR systems. The milking platforms that we work on are generally, what you would call parlor style or rotaries, with a recent increase in the use of automatic milking systems. In terms of the industry that we're in, about 4,600 or so dairy farms across the country, with just under 1.4 million cows. So in some ways not too different to the herd size in Canada. Our average herd size is about 300 cows per farm. And it's a significant industry. It's the third largest rural industry for us here in Australia. Now, to service that industry, Datagene, just to kind of provide a little bit of context about who some of the players are, because that might help in the rest of the presentation. Datagene is the organization that provides genetic evaluation and other services to the Australian industry, and increasingly to colleagues in other parts of the world. So we are responsible for holding the centralized database of herd records, providing genetic evaluations, full genetic evaluations on a weekly basis. And we also provide software services to colleagues in other industries, other agricultural industries, both in Australia and overseas. I've spent 15 years with Datagene and its predecessor. It's a member-based organization, so we are owned by dairy farmers, by our industry body, Dairy Australia, and by members who are mostly commercial service providers working in the herd improvement space. So these are herd recording centers, bull companies, genomic service providers, and the like. So that's just a little bit about Datagene. Datagene sits in an infrastructure that supports the delivery of new services to farmers from research that's provided by Dairy Bio. Dairy Bio is a large research group that incorporates government, such as Agriculture Victoria, Dairy Australia, which is our dairy services body, and various universities, La Trobe University being one of them. So Dairy Bio provides the research, Datagene is responsible for the delivery, but we all have a role in the engagement, the listening process that helps make this wheel work a little bit better. We're co-housed in Australia with a couple of breed societies, Holstein Australia and Jersey Australia, and the National Herd Improvement Association. So being in the same building as the researchers and Datagene and some commercial organizations helps us to try and tie things in a little bit better. And this is a reasonably new development. Datagene is about 6 years old now. But look, the investment in genetic research and delivery, the value of genetic evaluation, it only makes sense when we see results in terms of practice change. But achieving practice change depends on understanding the context in which that research is applied, and this really requires listening. So I'll give you a few examples. In Australia, we have breeding values for, it's actually not 40 traits, it's 45 traits these days. Like, friends in Canada, the list of traits is growing as we learn how to use the data and our processes to improve the services that we offer to farmers. And we have a range of similar breeding values to what you would find, in a CMAX catalogue, for example, in a dairy farm in Vasey, Ontario. I'm not going to go through them all. There's many more qualified people on this call that can speak about the traits, but I thought I might pick a few that were just a bit interesting. This is just the genetic trend graph for our main index, the Balanced Performance Index here in Australia. Is a familiar genetic trend graph. It shows an accelerated rate of genetic gain, over the last decade or so, which is not an uncommon story in dairy populations in lots of different countries. But I'm just going to highlight a couple, and I should mention above this line are the research activities that have delivered improved services, a better genetic evaluation offering. And below the line are the extension and development tasks that have supported the research and the implementation of the research. I'm not going to go through all of them, obviously, because there's quite a few there, but I'm going to highlight just 4 examples where I thought listening played a really important role. And the first is an old trait. This trait's been available, for almost 40 years now, and it's the trait of likability. But it's a great example of listening to farmers. So the likability breeding value is ask farmers a question. All things being equal, would you like more cows like this one in your herd? Sounds like such a simple question. The score is a subjective score from A to E, being, yes, an A is one of the best cows in my herd, through to E is I plan to sell the cow. And this score is taken once in an animal's life when she's a heifer. So within the first 4 months or so of her settling into the herd, she gets a score. And you think, how could a score like this possibly impact on the profitability of cows? But when we look down the track, it's actually one of the most useful traits in predicting the trait of survival or longevity in young animals with limited information. So when an animal's young and we don't have its entire lifetime to judge whether that animal has long survival or not, likability is actually one of the best predictors of that trait in young animals. And that's a remarkable trait, but it just reminds us of the value of listening to farmers, because they do have their own insights into the value of the animals. So it's a bit of a catch-all trait, and it allows farmers to emphasize the traits that they think are important to their herd. The second example is listening, but kind of in a different way. This is the heat tolerance breeding value. And this is probably actually about listening to the environment or listening to the climate. Um, uh, Canada gets hot in the summertime, so does Australia. And when cows are grazing on pasture, they don't have the same support in terms of cooling, such as the shade of a shed or sprinklers or big fans to help mitigate that. So we do have to think carefully about the role that heat plays, particularly during the summertime period. And as temperature and humidity increases, milk production decreases. And if we think about what's going to happen over in the future, we do obviously expect that the issue of heat tolerance or the impact of heat to increase as time goes on. So it was important to kind of think about how can we breed for more heat tolerant cows. So the heat tolerance breeding value was introduced in 2017. And what does it do? If we've got two cows, and as temperature and humidity increases, they're both producing milk, and to a certain point, they can produce about the same amount of milk. But some cows, when it gets more hot and have increased humidity, some cows seem to be able to tolerate that little bit better. They reduce their milk yield, but not to the same extent as cow B. So we would say cow A in this example is more heat tolerant than cow B. So that's the trait. We produce that for bulls and cows, and helps us separate those animals that seem to be able to tolerate those hot and humid conditions just that little bit better. And that's been nicely validated with some experiments at Ellenbank, a local research facility. Now, if anyone wants to have a conversation or wants to start up a conversation with a farmer to spend some time listening to what they say, I suggest you ask a farmer what makes a good cow. If you have a group of farmers and they're all talking about what their version of a good cow is, you might find that it's not all the same. And it's a great opportunity to hear the things that are important to a range of farmers. And it's that same question that we asked back in 2013 was the first time that we really started seriously asking this question. In 2013, we were listening to farmers, but we weren't necessarily liking what we were hearing. There's a relatively high use of imported semen, and those bulls were being selected on the basis of indexes in other countries that weren't really tuned to the Australian environment. The rate of genetic gain wasn't brilliant. It was a bit ho-hum. Genomic selection was underway, but as we know, genomics is a great accelerator, but we still need a steering wheel to set the direction of selection when it comes to running a good breeding program. So we set about listening, and we used what we called Australia's longest farm walk to do it. Now, farm walk is just it's like a barn meeting in Canada. It's just a chance for farmers to gather and chat about whatever the issue is at the time. But we thought we might do this in a bigger way. So we ran 26 events on 46 farms around the country in a 6-week period. We traveled to every dairy region of Australia. In addition to that, we ran an 1,000 Minds survey in conjunction with our friends at Abacus Bio, and that gathered feedback from more than 550 farmers. And what did they tell us during this process? They told us that profit remains the focus for herd improvement, that there are differences in breeding preferences that can be grouped into sort of 3 typologies, but they aren't linked, those preferences, by region, climate, farming system, calving pattern, breed, any of the other ways that you might group farmers together. So we listened to those 3 different sort of typologies, listen to the way that farmers were ranking traits and the different ways that they might do that. And what that meant is that we had to work harder when we're looking at the economic models that we're using to find the value as farmers were describing it, to make sure that that was included in the economic weights for the index. And in fact, we ended up with more than one index, recognizing that not all farmers were breeding in the same way. And just an example of that, the trait of milking speed was a good one, because farmers were talking about the labor cost associated with milking speed. So it wasn't just about the impact on mastitis, it was actually about the labor cost of having to deal with cows where cup slip was an issue. And that asked us to look at a secondary trait mammary system, because we wanted to avoid that cup slip. And so we were able to add an additional labor cost to mammary system, which increased the economic weight of that trait in the index. Now, there's a 5-year cycle that runs around this, a 5-year cycle that runs around the index, and this gives us an opportunity to review what we're hearing from industry, review industry priorities, look at scientific developments that have happened in that 5-year period in order to produce the next breeding objective. And if you want to hear a little bit more about those, there's a couple of papers that I've just highlighted there that are helpful if you are interested in that way that we developed that particular set of indices. So the 3 indices that we have now in Australia, the Balanced Performance Index is our main economic index, a health-weighted index that prioritizes traits like longevity and fertility. And the recent one, Sustainability Index, I saw that you had seen a seminar from Shelley not too long ago. So Shelley Richardson was certainly quite involved in the preparatory work to prepare the Sustainability Index that was delivered in Australia earlier this year in 2022. So it's fine to do all this work to put things in place that seem to make a lot of sense. However, it's important that we track to see if what we've done is actually hitting the mark. So I'll come back to this genetic trend graph and just highlighting on the genetic trend graph where the BPI was introduced. There are 3 ways that we track to see if what we're delivering is hitting the mark. And one is the genetic trend graph. At the end of the day, if farmers are using better bulls and selecting better heifers, we're making faster genetic progress, and this gets us faster towards our goal of achieving higher profit. The second is a change in market behavior. So we watch for how are bulls promoted in Australia? How are the companies talking about their bulls? Because that's an important signal as to what's landing well in the marketplace. The third is the use of genomics to pre-select bulls, because there was a change in how companies were using genomics from just selecting the bulls, then genomically testing them using the Australian system to get some genomic figures for Australia, to moving that forward in the process so that we're now screening over 6,000 bulls in Australia, which is up from just 500 or 600 bulls a few years ago, and that's certainly helpful in terms of identifying the bulls that are best fit for the Australian environment. We also conduct 3 yearly surveys with our partners at Dairy Australia, and they ask questions like how much influence does the BPI have on their selection? And those survey results are really important to us to be able to see, how things are landing and whether changes are required. But the numbers on the page, they aren't good enough. In a margin, delivered in a margin-driven dairy environment, every input is questioned. We have to prove the value of the input. So what is the value of higher genetic merit bulls? And in a time when, if we think back to, in the 2013 sort of, time era, people were really quite concerned about fertility and the fact that we hadn't incorporated fertility at a high enough level early enough in the process. And so in some ways, the higher genetic merit bulls kind of did a bit of damage. And so that's a question that people are asking is, you're presenting me with new numbers. Does it have value for my system? And making sure that I don't want it to do damage to my cows. So some of the questions that farmers were asking us, in addition, is, I'm a seasonal calving, 100% pasture-based system. Does it work for me? Because I'm not like my neighbor who is feeding a higher level of supplementary feed. I've heard that high index cows, they just fall apart. They don't last. They, milk well for a couple of years and then they just fall apart. Are high index cows really more profitable? So yes, you can have more productive cow, but that doesn't necessarily mean that she's a more profitable cow if the costs of supporting her exceed the additional benefit of the extra production. Fertility, it's mostly related to management. How can genetics possibly make a difference to fertility? And the last one is our cows are housed. They're not pasture cows. We feed them a total mixed ration. Is this going to work for my system? So these are sorts of questions that we would hear from farmers, and in validating the BPI and our breeding values, these are the questions that we wanted to answer. And so we worked with an epidemiologist, John Morton, who did a lovely job at collecting detailed feeding system information from over 500 herds around the country. And each of the feeding systems is here in a different colored line. So the black one, these are herds that are fed very little extra supplement. They're mostly on a pasture-based system with very little extra supplement. The pink one is a pretty standard system. This is a, still mostly grass based with up to 2 ton of grain fed per cow per year. The blue is where we've got some grazing, plus there'll be periods of time when we might have a partial mixed ration fed in addition. So, some sort of extra mixed feed that's added to the diet from time to time. Then there's a hybrid system, which means that it could vary from season to season, and they see a little bit of grass, but are mostly on prepared feed of some sort. And then the green is what many in Canada would be most familiar with in terms of a total mixed ration diet. So we grouped herds across these 5 different feeding systems. And what we were interested in is, does it make a difference? If we are using high genetic merit animals, does it make a difference? And so along the x-axis, this is the cow's sires balance performance index, and then the milk yield is on the y-axis. So even in the systems where there's not a lot of supplementary fed being offered, so they're mostly on a grazed system, so the energy going into the cow's diet is overall lower. We still see an improvement in milk yield for cows whose sires are higher BPI. And as we increase the intensity of the diet, if you will, up to the TMR, the benefit gets even greater. So in all of those 5 feeding systems, cows are producing more if their sires were high BPI sires. And when we look at this second important trait here, it's not only about producing more, it's also about lasting longer. If we've got a cow that's producing more and she's lasting longer, then it's pretty clear to identify that she's a more profitable cow. So the same feeding systems again. So the black line is our grazing, basically grazing only sort of system with a low amount of supplement. The pink is a system that's used quite commonly across the grazing plus up to 2 ton of supplement being fed per cow per year. The blue and yellow are some ones in the middle, and then the green line is our total mixed ration group. And this was the interesting one, the green one, because what we see here is as the cow's BPI, cow sires BPI increases, there's not very much difference in the survival. Those cows are the same percentage of those cows are being recalved by 20 months. And I think that was a great story for us to see, and really made us feel really quite confident about using these indexes, and even the more higher input systems, because those animals are lasting similarly, but we saw on the earlier slide that they're producing quite a lot more, so they become quite profitable cows. And in all of the other systems, as we increase BPI, the longevity of those cows actually does increase. Now, Joe Newton and colleagues at Agriculture Victoria, was the primary lead on a project called Improving Herds. And her analysis, she was interested in taking it one step further to not only look at performance in terms of milk solids produced and how long the cows lasted. She wanted to look at the actual profit of those cows. And so in this is a smaller group of herds, but they're herds that have very high quality financial data and animal performance data, genetic data. And in this case, she was, highlighted to us. This is an example for one of those herds in the study. Just the massive range that exists between the best and worst cows in the system. So each one of these dots is a cow in one herd. This is the average milk solid yield. This is a Jersey cow, so we're just over 450 kilo milk solids for, in this case, the Jersey herd. And we saw some animals down at the end, they didn't produce any milk solids at all. So those animals didn't really last in the herd long enough to even get to, one or two herd tests. So didn't produce virtually anything. And then we had some other cows up at the top end that were close to 700 kilos of milk solids produced. So this is within one herd. Now, if we look at the value, so I've changed, this is the same herd. All I've changed is the axis here, and this is the value of the milk income for those animals in that herd. So some virtually produce no milk value, and others are producing close to $4,000 worth of milk solids. Now, this is back a few years ago, so it'll be worth more now, but almost $4,000 worth of milk solids in a lactation. But we know that it does cost to rear those animals. And so when we look at the actual profitability of those cows, some were at negative costing almost $1,300, and others were yielding a profit of a plus 2040. And what we were able to, through this study, the higher BPI animals we're delivering on average about $300 additional profit per cow per year compared to low BPI cows in these herds. And that was helpful to be able to not only look at improved performance, but also improved profit from higher genetic merit cows. So, listening to the questions was really helpful in helping us establish some projects that I think were pretty nice validation studies that supported the use of Australian breeding values and of our indices for Australian farmers. A change of slant now. I've covered kind of, some different breeding values that we've seen along the way. But I'd like to kind of change a little bit to look at something about, look at the use of heifer genomics in Australia. We know that the range between best and worst is massive, say roughly $300 profit within a cohort even. And the proportion of calves that have missing or poor parentage in Australia is about 20%. So if this stuff is working really well, we want to identify who are the best animals as early as possible, and we want to make sure we're picking the right animals by having correct parentage. But the tool that we can use is heifer genomics. But the growth in heifer genomics wasn't really where we wanted it to be. So we put together a team about in 2020, a multidisciplinary team, and it's got an ambitious goal of testing 300,000 heifers each year by 2025. Now, yeah, we're in the order of 60 or 70,000 animals, so we've still got a ways to go to get to 300,000, but that's what the goal of the project was. But we still had to use listening as a tactic to understand how we could get from where we are now to where we wanted to be. And the first thing that meant is we had to do some market research to understand what was happening. And one of the classic quotes that came back from that is, that the awareness and understanding was pretty good, the awareness level was pretty good in terms of genomics, but the understanding wasn't there. And one of the interviewees, said that nobody wants to look silly and admit that they don't know about genomics. And so that gave us some really good leads in terms of how we needed to put something together that would help to lift the dial on the rate of heifer genomic testing. So some of the areas where understanding was limited was we weren't sure how much it was going to cost, weren't sure about the logistics that you would need to get over in order to be able to test your heifers, didn't quite know how to use the results, and certainly weren't clear about the value or the benefits that genomics could deliver. So there's some barriers in the way, and one of the biggest barriers for lifting the rate of heifer genomic testing was just getting some space in a really busy environment. If we think about all the things and all the decisions that farmers need to make each day, it's a really busy spot. And genes and genetics and genomics is just one little sliver of a very busy puzzle. And so really, in order those farmers who were able to test and were getting value from the test, they had worked out a way to overcome these barriers. So they understood that their business is ready for it, that they had enough replacements to be able to do some good selection, so it made sense for them. People that had tested had overcome the barrier of cost because they understood the value of the test. They figured out the logistics, found a time in their process that it made sense for them to genomically test routinely all of their animals, and they're confident in interpreting the results. So the genomics project has, three components. One, we had to improve the genomic pipeline to deliver the results more quickly. We had to ensure that we had strong communication and extension components that supported decision making, and work closely with our commercial partners to collaborate around this project. And some things that we did to improve the service offering was reducing the turnaround time from about 25 days to about 7 days for a sample. So the time it takes for us to return a result after receiving a genotype is down to about seven days. So we're now delivering full weekly genomic and genetic evaluations. Introduced new breeds so we can run genomics of red breeds, and improved the service offering so that commercial partners could use the service more easily. Just a couple of examples of some of the extension material from podcast webinars, typical things that we see the Canadians doing all very well as well to support learning and decision making when it comes to genetics and genomics. And some nice improvements in terms of the numbers of animals that are tested over the recent years, which supports the work in the project, both on the female side and on the male side. Just a couple of stats from the most recent Animal Husbandry and Genetics survey. So this is a survey that's done 400 randomly conducted interviews across Australia, and there's quotas set to make sure that we cover each dairy region and each type of farm. And we ask a lot of the same questions every 3 years to kind of keep a good gauge on what's happening. The thing I wanted to highlight is just there's a high level of awareness of genomics and genomic testing, 93% overall, which is nice to see. And it's greater in larger herds. So these extra large and double XL herds, this is about 500 to 700 cows in the herd, and these ones are over 700 cows in the herd. And the nice one in terms of are they planning to genomically test over the next 12 months? 20% of the people in this study are planning to test over the next 12 months. And, for us, that's in the order of 130,000 or so extra heifers tested. So that will get us much closer to our target. Now, at the Royal Winter Fair, one of the things you'll see lots of is the 4-H motto, learn to do by doing. And these next little bits are a bit about the research that I'm doing as part of my PhD with La Trobe University, which is really about farmers' questions about calves and calf health. And so what I'm aiming to answer through the PhD project is under what conditions is the measurement of genetic variation in calf vitality possible and practical. And I think there's an inherent value for improving the welfare of calves and make calf rearing less stressful for farmers. Many years ago, when I was working for a bull company, I would hear farmers say, I want more of that bull because his calves are rippers. So even, for quite a long time, I think farmers have been telling us that there are differences between calves, and I'd like to be able to put some numbers behind that. When we come back to that genetic trend graph, one of the things that we note is, there's very little on this graph that thinks about the young stock. They constitute about a third of our herd, so they cost a lot of money, but we don't really have a lot of breeding tools that are related to them. So we've got our old calving ease breeding values, we've got things like gestation length, but there's not a lot in terms of the survival, if you will, of calves. So Colin and I have had quite a few chats about calf traits, and we do probably, and it's interesting that the projects are looking at different calf traits, but just to define what I mean about calf traits in the Australian context, I'm looking at, fate, so stillborn, whether they're born alive or dead. Calf size and calving ease have been part of the picture for a while, but they are important when it comes to thinking about stillbirth. I'm also interested in pre-weaning mortality, just as a binary trait. Also looking at pre-weaning morbidity, so whether they showed some signs of illness. And then the farmer scored calf vitality, which is similar to the likability trait that I showed at the very start of the presentation, which is about farmers' views on whether the calf is a good calf or not. About 7%, or just under 7% of calves are born dead in Australia. So it is something that is worthwhile having a look at, because when you multiply that out across a population of cows, that's quite a few dead calves. And so that it makes sense to do something about that. The first breeding values, the most promising one is the maternal breeding value for stillbirth, and about 10% difference in stillbirth between bulls that are average and bulls that are plus 0.1. So there is seems to be a bit of scope, even though it's a very lowly heritable trait. Our heritability is, for the direct trait is, 1% on a good day, and it's a little bit higher on the maternal trait. And the breeding value correlation between the direct and the maternal is pretty good, strong and positive, about 0.53. So in the Australian data, reasonably strong genetic correlation between a cow's ability to deliver a live calf and calving ease. Calving ease is important in this story. and more cows deliver a live calf when the calvings are easier. And that makes sense from an on-farm perspective. So these are some early data that using historical historical data over the past couple of decades or so. So the data is a bit scrappy, as Colin's as we've discussed in the past. It's a bit scrappy, a little bit hard to work with, but there's a little bit of glimmer of hope here that we can do something in terms of improving the services to farmers that control stillbirth. When we think about stillborn as a maternal trait, so the cow's ability to deliver a live calf, the genetic trend for that is seems to be improving, which is nice. The differences are very small, but at least it's heading in the right direction. So if an upward genetic trend in this case is a good thing, an upward genetic trend means fewer stillbirths. But we're still at the kind of early stages of this project. I suppose a note of interest that we're been collecting data for a couple of years now, gathering genotypes and phenotypes on both dead and alive calves. So that will give us some, a little some more depth and greater quality of data that will help us hopefully improve the breeding values that we've generated so far. So I suppose when we think about coming back to the the point about listening, we try to predict a lot of things when it comes to genetics. And if we think back to WC Gelp earlier this year, there's lots of talk about ways that we can predict things. So we're all fascinating to learn about. But can we predict the effect of listening on improved practice change? And I'm going to propose a model that I think this depends on listeners, and probably more than one, a team of listeners that has the capacity to do something about it. Which means we, being in line with the priorities of industry, that enables resources to be available to actually do something about the problem that a farmer might be expressing. The capability. It almost always takes a team to do this stuff, and it's almost always multidisciplinary. It also depends on the quality of the explanation back to the producer, and I'm going to say the validation or confidence, maybe, that comes from the validation and monitoring of metrics. And so, can we improve the effective listening on changing practice on farm? And I think we can if we listen, if we've got the capacity to do something, if we've got the capability in our team, if we're being able to explain things really well, and if we've got good, strong validation and metrics monitoring to back that up. So thanks very much for the opportunity. Look, this work that I presented today is from a large team. I'm not going to name all the people individually because there are quite a lot involved in those various projects, which I'm all very grateful to. Yeah, it takes a team from farmers to extension, people that are specialists in practice change, researchers, and those that are guiding our industry, leading our industry to work together in order to make some good improvement here. So I'm going to close off there, Colin, to give us an opportunity to have some questions, and I'm certainly looking forward to observations or suggestions that people might have. And I maybe stop sharing my screen to
that would be perfect.
make it a little easier.
Yes, thank you, Michelle. Great presentation, touching on some very important points. I see we already have our first question. Murray, work away.
Thank you, Michelle. My name is Murray Hunt, and
Hi, Murray.
How are you?
I'm well, thank you.
And novel approach, thank you. This is maybe not directly related, but what percentage of the service cost in various services is covered by government, and what percent is covered by producer paying, for services? Could you comment on that, please?
Yeah, that's a good question, Murray. And look, I'm not going to be able to give you an actual percentage because I'll get that absolutely wrong. But I can tell you where government has a role to play here in Australia. Yep. So Dairy Australia is our services body that in it provides extension, marketing, funds research, development, innovation. And it's a farmer checkoff, if you will. So on our farm, we would contribute about $6,000 a year from our farm to Dairy Australia, and it's matched dollar for dollar with government funding. So so that under an agreement, a national agreement. So that's one way that government contributes. A second way is they do fund people, they employ people that conduct the research. So Agriculture Victoria, our state government, has quite a big team of researchers that they fund in partnership with Dairy Australia to provide the capability to conduct research. So that's another way that government contributes. So we don't have a lot of government subsidies per se, on farm, but government is certainly involved in the R&D that supports agriculture because it's of economic benefit to our country to grow what is our third largest rural sector.
Thank you.
Perfect. Thank you, Murray. Other questions? Well, no. Did you put your hand back up, or I see it pop up again?
Yeah, I have another question.
Yeah, work away.
Try to understand. A long while ago, I started a project when I worked for Holstein Canada on milking speed, and that's kept going, and thank goodness it has, and everything. And it's all farmer input. Is there any conflict between the research community and the farmers about how data is captured? Like farmers is an opinion, or I like this one, I don't like that one. Is that ever a discussion point?
There are we have three traits that we gather farmer scores on. So milking speed is one of them. We don't have any timed recording of milking speed in our evaluation, so it's all farmer scored. Likability is a second trait, and it's different to milking speed. So likability is that overall, if I had my time again, would I have this cow in my herd? And the third one is temperament. And those are three separate and distinct traits. They are collected at the same time in the same mechanism, but they're all three farmers scored traits. Look, I've not got a sense in my time, so I've, been doing this sort of stuff for 15 or so years, and during that time I've not come across people questioning whether the farmer scores are right or not. From time to time people always say, "Oh, is that good enough? Is that subjective score good enough?" But look, it seems to be we have reasonably strong economic weights for both milking speed and temperament in our index, and likability contributes to the evaluation of survival breeding values. So they're well used. So I haven't picked up that sense, Murray, so far. Certainly, there's great use of technology down the track that maybe you could start using more subjective scores for things like milking speed. But at the moment, we seem to be reasonably satisfied with the use of farmer scores. Farmers know cows. They know what's a fast milker and a slow milker, and I think it's good for us to listen to that.
Thanks, Murray. Christine.
Hi, Michelle. What a fantastic presentation you just gave. That made me think about a zillion different things, and I have a zillion different questions, but I'm only going to ask one. I really liked the idea of listening, and I really liked the sort of feedback that you guys could give your producers after doing all of that research. One thing that intrigued me was and I think I saw it correctly, but when you were showing the willingness to adopt genomics in your herds, on the very last row was the farmers who understood or thought they understood genomics, but who were unlikely to implement it. And I think I saw a number like 46% in your XL herds that knew about genomics but were not willing or unlikely to use it. What do you think is the reason behind that?
Yeah, actually, I don't know the reason behind that, Christine. It may be the hurdles that we've already identified, just not that at this point in time, they don't understand the value of it. They can't see that it's going to contribute to their business at this point in time. That may be the case. I think our job is to listen and to find out. We were quite excited by 20% wanting to test in the next 12 months. Because that will kind of, that will, triple the numbers that we're doing now. If that's, if we can take that from maybe to yes, but obviously a next step is to understand in those very large herds what is it about it that where they can't see the value at the moment that we could do something. It's reasonably expensive for us to genomically test. So there's a really good value there. The turnaround, the time it takes to recoup the cost of genotyping in a single year is about 5 years when we look at the net present value of it. So it does take time to return that value back to farm, and that in the order of priority of the things that those herds want to invest in, that might still be too long for them to take that up. But we need to find out more. No, Christine, that information's hot off the press. We've only got those results in the last 3 weeks or so, so it's still a work in progress. But, thank you. And if you've got other questions, oh yeah, go. I was going to say you're welcome to
can I ask
email.
One more. I don't want to hog the.
Yeah, work away.
But I do have another question about, and I think I saw this correctly as well. The difference in dead calves stillbirths between males and females in Holstein, that was actually quite considerable. I think 12% of the males, and are they crossbreeding, or what do you think is behind that?
Yeah, in that analysis was on Holsteins and Jerseys separately. So I took the crossbreds out, so I didn't get myself confused, essentially, to start with. So that's just Holstein. But if we think about the link, and this is over time, remember, we've made some great improvements around the world in terms of calving ease. So our calvings are easier now than what they used to be, and this is historical data looking back almost 30 years. But if we think about bull calves, generally larger in size, and those cows that had difficulty, or those calves that were born with difficulty, about a third of them, if they're born with difficulty, died. So if we know that bulls are larger, more difficulty with being in terms of calving ease, then I think it makes sense to me that there's a higher proportion of those calves that are born stillborn compared to their female counterparts. There's a few questions in my mind because the Jersey numbers really stand out as well, and I'm just wondering if there's something in the way that the data is being recorded on Jersey bulls. Coming from a Jersey farm, I hope people won't mind me saying this, but a relatively lower value calf, and I'm just wondering if the care is not being taken necessarily to record those calves very well. So we might have a few more being recorded as dead that are maybe not really dead, but it's just easier to record a calf that's dead than a calf that's alive. So whether that's also inflating that number a little bit as well. Yeah. But certainly there's enough calves there to warrant, I think, some investigation to see if we can do something about it.
Absolutely. Fascinating work, Michelle. Thank you so much for sharing that with us. That was awesome.
Thanks, Christine.
Thanks, Christine. Murray, do you have another question?
I don't want to get in front of somebody else if there's other questions, but yes.
No, you can fire away. No one else has their hands up.
Okay. Michelle, I've always felt the same as you, that farmers know what's happening on their farms. But when I'm speaking with my friends, mostly in the United States, who milk thousands of cows, their herds do, and the average herds with 1,000 cows or more in the United States produce 2/3 of the milk that comes out of the United States, and everything's heading that way. And if we didn't have quotas in Canada, they'd be heading that way faster too. That's my bias. Sorry about that. But at any rate, what I'm thinking about is how in the future, is there any discussions, or just from your own information in capturing data for calves and for these other traits, auxiliary, I think you called them management traits. Sometimes they're called functional traits. How will we be able to get that data? Because farmers want it, but some want to be paid for it. And do you know of any discussions that are occurring? Because I see that as the limitation, is the data that we'll have to use in the future. Do you understand where I'm coming from? I think.
Yeah, I do, Murray. Yeah, no, and it's a really tricky problem, that one. Yeah, because if people have invested in technology, they sort of think, well, we should all share in the investment, in terms of being paid for some of that data. Look, I think it's certainly something that we need to be talking about, but at this point in time, we've outside the odd person. We've not been, seriously asked for payment in terms of collecting that data. But as you say, as time goes on and we're using tech, it does become tricky. One of the things that could be helpful to us, and that's been working closely with the tech providers and making sure that it's really quite easy for that information to be shared. There are multiple ways of being able to move data around, and if we're doing it in a collaborative way where we can see how, with for not much investment, we are able to share that data a little bit more easily. I think that's a good step forward. But whether everyone's willing to do that is certainly an outstanding question, Murray. So I don't have a secret answer that's going to fix that one, though, but it's certainly something that we need to keep on the radar. And I think listening to people is probably a pretty good first step.
Thank you, Murray. I actually have one quick question for you as well, Michelle, and it's with regard, I know you're still under the data collection point regarding the ripper calves. And have you thought of or even looked into initially, is there an association between a calf that is classified as a ripper that also becomes a very likable heifer and thus has long longevity past that point?
Yeah, that's a fascinating question, and I'm not yet sure if I'll be able to answer that just from the time period. But we're closing down data collection sort of at Christmas time, so I'll have 3 springs, 2 years worth of data to work with. It'll be a fascinating discovery to see what the link is between likability and a ripper calf. Also, other traits like overall survival and milk yield. Can we identify particular aspects of calves that they're more likely to be successful in the herd down the track. Yeah, over and above the good genomic breeding values that we already have for those calves.
No, yeah. That's great.
It'll be fascinating. It'll be fascinating. Yeah.
But is it something that you would probably, once the data infrastructure is there, that they will kind of look to see over time? Because yeah, if you could identify a ripper calf that has a strong association with having good longevity, it's a great indicator to have so early in life.
Yeah, it would be. Although the genomic test, like we can get that back kind of in 6 weeks or so by the time we take the sample, send it overseas, comes back, gets evaluated. We've got that certainly before weaning. So we still have that as another tool in terms of checking out the prediction for survival. But the just a note on the pipeline. Sorry, Colin, I'm not answering your question so directly, succinctly. On the pipeline part, there isn't a pipeline at the moment for recording the calf vitality trait. It's an experimental trait, so at the moment we're recording it using Excel spreadsheets. I've got calf recording school notebooks, for example. This is the way that we're collecting that information on probably 15,000 calves or thereabouts. And so that's all paper-based at the moment. So there's no system of recording calf vitality right now. I think we need to prove that it's a useful thing to do before it would be put into systems that would do that on a more streamlined and routine basis.
Okay, that makes sense. I mean, I'm sure that would be a great selling point if it was that these will turn into more likable animals later on in life. But no, that's perfect. Do we have any final questions for Michelle? seeing any, and I'm sure, Michelle, you might want to go back to bed for a couple of hours, so we will hold it up there. I'd just like to thank you again, Michelle, for the great presentation, and thank you all for the great questions as well and discussion. See you all next week.
Thanks, Colin. Great to see you, folks. Lovely.
Yeah.
Thanks so much, Michelle. Thanks, Colin. Take care. Have a great weekend.